So today the lecture will be on the science of trichloroethylene, or TCE, and Woburn, Massachusetts. So if you've seen the movie or you've heard of the book, Civil Action, if you want to watch them, they're great. The book is much better than the movie. And so today I was going to talk about that and discuss some of the work behind it. So, as we've been discussing in this class, there are immiscible chemicals, D-naples, and L-naples. TCE is a D-naple. It is a dense non-aqueous phase liquid. It's a sinker. It sinks because of that chloride that's inside of it. And remember, TCE can stand for trichloroethylene or trichloroethylene, and it's spelled differently, but it means exactly the same thing. And we talked about this before, where this would get into the groundwater supply, and it pollutes a larger area than L-naples, which are floaters. So D-naples, again, this is the movie A Civil Action. This was used a lot, this TCE, and we talked about the pollution before, for dry cleaners, cleaning for electronics. It's a great solvent. I mean, works great. I mean, better living through chemistry was a great idea. And so this is part of what this chemical came into here, was that, and then back in that time, when this first was it was just dumped into the backyard, into there. And so the migration of this, and we've shown this before, it can get into there, it can go against the groundwater flow, it can go against it because it goes by gravity, and it sinks and it causes a lot bigger spill problem than other ones. And if you guys remember, it can get into here, it can get into the clays and just stick around for everything. So TCE, especially D-naples, can be a lot of different things, especially halogenated compounds. Pesticides can also be D-naples. PCBs, we didn't talk about those in this class, but you can look up PCBs, polychlorinated biphenyls, and get some more information on those. And then they also have common names. We already talked about this. And, what were they commonly used for? They were commonly used for fats, waxes, electronics. They were manufactured chemicals. They were used for pharmaceuticals, dry cleaning, plasticizers, PCBs or heat transfer media. And they could get into groundwater from a lot of different sources. So they could get in there from underground storage tank or lust sites, storage drums, buried spills, intentional disposal of them. So one of the things that happened was back in the 1970s and even before then, you would just dump these chemicals in the backyard. They were VOCs, they volatilized very quickly, so it would just go away. And so we didn't worry too much about them. And so they were just dumps in the back of property. And I'll show that, especially with Woburn. Some of the reasons that it makes it a great groundwater quality problem is that it's highly volatile. It has high density, so it sinks to the bottom, low viscosity, so it runs really fast. It has low interfacial tensions. It has low absolute solubility, but relatively high solubility, much higher than the SOP. Low partitioning into soil, and then biodegradation does not happen on these compounds. So they just sit around because, again, man-made compounds. So what I really want to focus on today is Woburn, Massachusetts. So that was just kind of putting your mind around the idea of TCE, kind of just a brief introduction back to it if you don't remember what it was. Okay, so what I really want to focus on today is this idea of Woburn, Massachusetts. Woburn, it's an old industrial town. So there was tanneries that started there since the 1844s. Their school mascot is the Tanners. So what they would do in this town is they started off, Massachusetts, it's a place where they would take animal hides and make them into leather. And so this was one of the big industrial products in that town. And then the whole town started to become more industrial with time. So other industries came into the town all along along the rivers and stuff, and so it just became an industrial town of Massachusetts. These are some pictures from the 1970s of the town. You can just see all the barrels just kind of thrown everywhere, different chemicals. This was kind of the proper way of disposing things before the Clean Water Act, Clean Air Act. Before we had the Environmental Protection Agency and enforceable regulations, this is what would happen. We would have barrels just everywhere on somebody's property. Chemicals would leak. They would get into water supplies. And so these are pictures actually from Woburn, Massachusetts at the time of the civil action. So these are things. So what happened with Woburn, Massachusetts. So Woburn, there was a cancer cluster, And so people who were living right over in this area of town, and we'll show you, these are the clusters of where the cancers were in town, but there was this cluster over here. And the families noticed that everybody was getting sick, that children were dying, people were coming down with leukemia, neighbors would talk to each other and be like, so-and-so else died, somebody else is sick in this town. And they started noticing that there was problems, especially in the summertime. So in the summertime, the water would smell funny, they would get itches and rashes on their skin, especially people over on this side of town. And what we looked at, when they looked at TCE and they looked at this, eventually what they found out was that the Woburn, Massachusetts wells G's and H, here's wells G and H, here's wells G and H, were contaminating the town. So during the summertime, when you need more water, so generally for a city, during the summertime there's increasing water use. Why is there increasing water use? A couple of reasons. First of all, people drink more water during the summertime. You're outside, you're active, it's hot. More water is used for pools, watering lawns. You can think of a whole bunch of reasons. So water increases use in the summertime and decreases during the wintertime. So, and especially if it's a dry year, use will increase because people need to water their lawns. Why? I don't know, but that's what people do. So a city will always have backup wells. So in the city of Woburn, Massachusetts, they had these two backup wells G and H, that they would only turn on when they needed the extra water. And generally that was in the summertime. The other thing that happens when you turn on wells inside of a community is that water is not evenly mixed between the entire city and then everybody in the town gets exactly the same water. That's not exactly what happens. So wells that are closest, or homes that are closest to a well, when that water gets pumped up and put into your local water tower, it gets fed to those different those homes differently. So if you are in the city of DeKalb and you're getting your water mostly from one water tower versus the other water tower, if there's problems with one water tower, you might be okay if you're using water from the other water tower. So, or as it's getting mixed with inside of the system, we can see variations in the concentrations across the city. So this is part of what this is the MCL for TCE is 5 ppb. I keep saying that, and I hopefully, if you remember the first day of class, that was one of the first things I said. Now it makes total sense to you. So the MCL for it is 5 ppb, and so anything that is in here, even in the baby blue, the middle blue, or the light blue, is above the MCL for TCE, and this is TC plus PCB concentration. So all this part of the town, you can see the different colors. So this was a modeling exercise they did, which shows that this part of the town, and you can see the numbers on here, this is the concentrations of the TCE that those homes received inside of that area and stuff. While the pumping rates for the wells were about 707 gallons per minute for G and H, was only 432. Those wells which were high in TCE were pumping a lot of water right to this part of town. This is where the cancer clusters were. All the red dots are where the cancer clusters were. This is where one of the cancers, and if you look, there's kind of like this side of town got a lot more of the TCE inside of it. One of the things that I wanted to talk to you a little bit about was TCE going and being biodegraded. Now, I did say TCE doesn't biodegrade. It does. Microorganisms finally figured out how to get it. It's not really liked. It's only done under anaerobic conditions. It's done very, very slowly, and because they don't really get a lot of nutrients out of it. It's what's called co-metabolism. So they're eating something else and then they happen to eat this at the same time. And so what will happen in water systems is you'll get PCE, or tetrachloroethylene, because if you notice there are 4 chloro groups around this. It's also called PERC and PCE. So it's tetrachloroethylene, but we also refer to it as PCE for perchloroethylene, or referred to as PERC. So that will degrade and it will remove one chlorine group, and so you get TCE. Now TCE on itself will also be spilled, so PCE and TCE will both be spilled, or PCE can turn into TCE. Then TCE will remove a chlorine. If it goes to the cis, this is biological. Trans does not happen biologically. This happens biologically. So if you see cis trans DCE, that's where the two chlorine groups are on the same side, then you know that it is biological. Trans, if you see a mix, an even mix between these two, then you know that the DCE was spilled. Because when they manufacture it with even amounts of cis and trans. It's kind of just mixed together. But if you see only cis, then you know that it's biological. So TCE will turn into cis DCE, which will turn into vinyl chloride. And there's only one. So when you say vinyl chloride, PVC, polyvinyl chloride, this is the main group that forms the polyvinyl chloride. And then if you remove it under aerobic conditions, so all of this happens under anaerobic conditions, going from vinyl chloride to ethylene happens under aerobic conditions only. Another little side note is that VC, vinyl chloride, is more toxic and is worse of a cancer-causing agent than any one of these three compounds. It's worse than PCB, it's worse than TCE, it's worse than cis-DCE, and so when this biodegrades, you're actually making a worse compound by making vinyl chloride. Also, vinyl chloride is a gas, and so it comes back up into people's homes. So when this starts to biodegrade inside of the environment, it actually can make it actually much worse, and then you have to go to aerobic to get rid of it. Okay, so this is what's happening in Woburn, Massachusetts. So Woburn water supply. In the 1860s, Woburn water was supplied from 6 different wells in the vicinity of Horn Pond. So this is Horn Pond over here. As the population grew, more water was needed, and so they put in wells G and H over here that were operated in 1964, and well H was added in 1967. So these 2 wells were added right here, right in the middle of the industrial park. So this is where there's a tannery over here, there's plasticizing plants, there's grays, there's a whole bunch of industry right around wells G and H in there. So what did wells G and H look like? Well, this is the actual picture from the time of the trial and everything. So here's the well house for wells G, here's the well house for H, this is the little well house for it, and then this is the geologic log for it. So one of the things that when we look at the geology of the site, because geology always makes a big difference on the construction of these sites, one of the things that we notice with the site is that it's in this giant valley. So what happened is we had glaciers came, the last glacial maximum. The glaciers came from the north and they pushed sediment south and they dug out. So wherever there was low-lying areas like valleys where rivers were occurring, the glaciers found those easier ways to transport, to move down those, and so they would scour out from the bedrock these valleys, these river valleys. So these became, if you ever look at glaciers, they're in like little valleys and stuff. That's what this is. This is an old glacial valley where a glacier was coming down here, scouring this out. And as the glacier's retreating, there's a river forming in there. And so we get sands and gravels, and we get all of the typical materials that you would see inside of a river. And so this is just a riverbed. And then finally, we still have the river that this is forming on right at the top. So this is a great place to put these wells, and if you look at the core log for installing these wells, it's all gravel. You can see this is all gravel and sand, so they're going to get lots of water out. So this is one of the reasons they put this here, is they knew they had this valley right here, and they could get lots and lots of water out. Even though there was industry all along the outside edge, inside of this valley that was right next to it was a great place to put in wells. So this is just another cross-section of it. This is more geologic. This is more artistic. This is more geologic. Here's wells G and H inside of here. And then what happened is if we look at the pollution that happened in the area, is people used to dump it. Like I said, TCE would get dumped at places. And I'll show you this model coming up here in a few seconds. But what they would do is they would dump it from all of these different sources. So we had Grace over here. We had a plastic company. We had a drum barrel industry right here, and then we had Wildwood, which was a tannery that's been around since, the beginning of their time for tanneries. They had their own well that they used for their tannering operations, and so some of the TCE kind of gets stuck on their property, which is really good. But you can see these brighter colors is really high concentrations. That's 10,000 parts per million of TCE, just going right into, I can't read it right now. Well, we'll see it in a second. Getting straight right to these wells, and you can see how wells G and H, when they get turned on, just suck all of this pollution right to them, and then this gets sucked right into the people's homes. Into there. So polluting was done in the area. This was pictures from the actual sites, from the Wildwood, from the Grace. They would just, one drum place would just put drums everywhere. So these are pictures that were just showing the amount of pollution that was just around those wells. So here's wells G and H, and so this is the former Riley Tannery site, which had its own well. There was another well here on Wildwood, which was the J.J. Riley Tannery property, where they would dump. This is where they would dump everything. Olympia, UniFirst, and Grace, and then National and Plastics. It was a plastic manufacturer. These were all the properties that were slowly dumping stuff on their property and going down into this well. So I'm going to show you a couple things. These are the links to them. Let's move this over here. Okay, so this is the first one I'm going to show you. So what this is called a sandbox, and I'll play this a couple times. So somebody created in a cross-section for lab visualization purposes. So here's the bedrock. Let's play this again. Play. So I'll pause it. So here's the bedrock. Here's they made the material same as what was happening at Woburn, Massachusetts. So sand and gravels. Here's some silt, sand and clays. Here's gravel right at base of the well. Here's the river. Here's all the different wells. Here's Grace. So this is one of the polluters, and they're dumping stuff in their backyard. They talk about it. They talk about how that was their disposal. There was a spot in the back of the property that when the electronics, the TCE was filled with dirt and grunk and stuff like that, they would wheel it out to the back and they would just dump it into this pit in the back of their property. And this was the way to dispose of it. This was the prescribed way to get rid of the chemicals at that time. And so they would dump it down there, and here it is. You can see it going, and you can see it just moving straight as this well is getting turned on. It's going straight to the river. And then as soon as they turn on the well, it goes right down into it. Let's see, let me go back to my slides. So it goes straight into the dye tracer, goes into there now. Dye tracer 2, let's get this one up. So that was what happens when the sampling goes, the water goes straight to This is when the water was not being pumped, and now this is a visualization showing when this well gets pumped, what happens to the TCE. So can you guys see a difference between those two? So of the original one I showed you, let's play this again. The original one I showed you, this just kind of went straight to the river. It didn't get to this well. Now all of a sudden, we turning on this pump, where does the pollution go? All of a sudden it goes straight, that well pulls that pollution in. You can just see it coming up to the municipal well up in here. So this is part of the pollution happens because of that. Okay. So what concentrations were they in the home? So they actually did some visualizations with that. And so we can look at, let's see, here's the distribution model. So here's the town, here's that PCE again. I'm going to play this model here. And this was done from Ohio State University. They used all of the data after the trial was over, and they after Grace was found guilty and Wildwood wasn't. They went through and actually did the modeling of the site and saw what happened. So what we have here is the actual pumping data from wells G and H, because they got all the historic pumping data from those wells. And then they made predictions based upon the city's distribution systems. They made up how the water concentrations would change with time, depending on the concentrations of the water, concentrations and how much water was coming in and how much people were getting exposed to. And you can see the times of the year right right over in here and the dates. And so, here all of a sudden, these people over in this part of town are getting lots of it. Now they're getting even more of it because wells G and H are coming on online. Sometimes you need extra water at different times of year. It's not just during the summertime, but depending on your town, you always have these backup wells. And so here we're, nothing's happening in the 1970s. Now, all of a sudden we're having high concentrations because these are the pumping rates that are happening in here. So it's just fascinating to watch how these modeling can occur. Now, one of the reasons these homes weren't getting it is, if you remember, there's a whole bunch of wells around this lake here, and so the main water for this part of town is really coming off of this lake, and so this parts of town, it's harder for the water to get into the systems. But if there's not as much water here, then that water would get into here. But you can see that it pulses in when there's problems. Whenever the city needs extra water, all of a sudden people are getting exposed, and at other times of the year they're not getting exposed at all to this. And so I think this goes through, let's see, I think that's it. Yeah. So hopefully you found that kind of interesting, how water quality can change throughout a city depending on the wells that were occurring at that time. So that's the animation that's on here. And then let's see, visualization. So one of the other things that they did was, so here's the PCE exposure to it. Here's a video showing the transport of it. Let's see if this will, oh, I don't want to do that one. I'm going to pause it for a second. Okay, so this first animation here, here's wells G and H, here's the tannery and Grace and everything else. I'm going to start playing this. What this is the percent of river water. So as wells are pulling in water, they're going to be pulling water from the river, and you can see how much they're pulling water from surface areas, from areas, local groundwater areas, and they're pulling in that water into these wells, and they're drawing in this water from this whole area right in here. So they're drawing in this river water, they're drawing in the water from the tanneries, they're pulling this water in 68 into the wells. And so you can see that. And so the more important one I wanted to show you was this one. Let's see if I make it a little bigger here. Okay, so let me play this one. Okay, so what's happening here is we've got Universe, Grace, we've got the tannery down here. Here's wells G's and H. They're turning on pumping when it's red. Here they're spilling it. Here's the 60s. Here's Grace putting it into the ground over in this area here. National something in plastic. It's National something of plastic is dumping the water into it, and then as the wells are being turned on, you can see that this is just pulling that water from all these pollution sources. But who's the first one to get the pollution into it? It's the tannery. Grace is actually at the end of the movie, and even at the end of the book in the court's case, Grace is found guilty for polluting the city, and the tannery is not found. No one of these other people are found guilty. Some of these people all settled out of court. These guys fought it. So if you ever watch the movie, it's actually really interesting. This is, you really hate this guy who owns all this property here, and he's the one who's just polluting the river. You can see Grace is still, it's not until the 1970s before that pollution even gets into it, and they're the ones who are found guilty at the end of the court case. And so who's polluting the samples? You can just see that it's just coming in, and then when the wells are turned off, the pollution starts to move downstream, down gradient from those, and then all of a sudden as the wells are pumped on, it pulls it back towards them. The other part of this that's interesting is you can also watch it here. Let me go back a wee bit. I'll put links to these up on the webpage so you guys can watch. Oh, there's the 1980s. And then they turn off those wells, they abandon those wells, and you can just see all the pollution going down. Now here's a cross section across G. Here's Wildwood. It's a DNAPL, so it sinks, and then as soon as the well gets pulled, it turns it on, it pulls it up. Here's the plastics company dumping it. It goes right along the bedrock, and then they turn it on, and it just pulls it towards it. Okay. Again, like I said, I will put these videos up online so you can watch them and just be like, Yeah, it's amazing. So these are the two videos that I just showed you. So what happened in the case? Well, the Woburns made the Woburn citizens' concerns were they were like the years of the toxic dumping. They noticed a strong odor in the water when the wells GNH were on. The water tasted bad periodically. It caused skin rashes. There was an apparent cluster of childhood leukemia in that neighborhood, and they found that the state and local officials were unresponsive. Like they would ask them about stuff, and they would say, "We don't know." And this now, remember we talked about GC? Well, GCs were just starting to come online at this time, so GCs were not really available at the time. And so really when this started getting testing was after the Clean Water Act comes in. Again, EPA, very important. And also we had better analytical equipment to be able to see that this was. So the results from the 1981 study looked at this town and said, yeah, there was about 12 cases of childhood leukemia that were diagnosed. There was no family for those 12 cases, and then this statistically showed that there was a cancer cluster in the town, which is actually really hard to prove. They looked at the city again, and they said this is where most of the clusters occurred, and this was the highest probability of the clusters. There was another Harvard study that looked at it, and they said that they did a telephone survey and they used the water distribution system, and they said that they estimated the contamination from wells GNH were twofold higher in childhood leukemia cases, so they really were linked to it as a case. And they looked at the water distribution system, which I already showed you, and they did a modeling to show where the water, and this is the distribution system, and came up with things. And they showed that people in those wells over on this side of town were more likely. And that when the contaminated wells were closed, there were still cases of leukemia that happened afterwards because they were exposed while they were children or even fetuses in there. And that some of these cases, and they did a whole birth study to show that there was a documented link. And just for the geologists and for the people in the room, this is the geology of the site, and you can just see this well, this river here. This is where they put the town. This was our area that we were doing the wells GNH. So hopefully from this lecture you kind of got a little bit more idea about wells GNH, Woburn, Massachusetts, and how TCE can pollute a site. I do highly recommend reading the book called A Civil Action. When I was getting my PhD, there was I was doing TCE as my PhD, and I would have guys read the book of Civil Action if they wanted to date me, so they could talk to me. So just so you know that. Okay, well, that's it for today.